Alright, in this problem we've been asked to use the Euclidean algorithm to find integers x and y so that 1 is equal to 222x plus 97y. At first glance, it's not even obvious that there will be integers x and y that satisfy that equation, but what we will discover is that 1 is the greatest common divisor of 222 and 97. That's where the Euclidean algorithm comes into play. Okay, so we use the division algorithm once, get a remainder of 28, so now we use 97 and 28. The division algorithm yet again gives us a remainder of 13. We use 28 and 13 to get a remainder of 2, and then 13 and 2 will give us a remainder of 1, and then, of course, the next remainder term would be 0. So the greatest common divisor is 1, then what we do is we take our remainder terms and we solve for them. And we're going to use those, starting with this bottom one, and we're going to substitute our way back until we get 222 and 97 as the coefficients. So we're going to back substitute to solve for x and y. So 1 is 13 minus 2 times 6. We look at the 2 as the, and we replace 2 with 28 minus 13 times 2. Then we're going to collect terms. So there's some number of 13, some number of 28s here. So there are 13 13s when we combine all those, and there are 6 28s. Okay. Then we're going to replace 13 with 97 minus 28 times 3. We make that substitution, and then we simplify. So there are 13 97s, and there will be 45 28s at that point. Okay, now we're going to take 28 and replace it with 222 minus 97 times 2. And then we'll collect our 97s and our 222s and see how many we have. Looks like there are 103 97s and 45 222s there. So we have actually found a value for x and a value for y. And this will work every time with the Euclidean algorithm. As long as those two numbers are relatively prime, then we can write 1 as a linear combination of those two values.